Hey, what's going on, guys? I wanted to make you a video. I know I have not been as aggressive on making them as normal, but I wanted to make you a video in regards to how to graph sine and cosine of trig functions. So let's dig in. You were recently assigned this worksheet activity for practice. Alright, now one of the things I want you to be able to do is I'm going to pick a few problems on this sheet and solve them and graph them. And I want you to see how it's done. Alright, so you can use this as a reference in preparation for your test and preparation for anything we got going on coming up. Alright, so let's get started. The ones I want to do is, alright, so I decided the numbers I'm going to do for you today on this video are 1, 10, 12, 13, and 15. Alright, and the reason I'm doing these is because the graphs are going to look significantly different, and I want you to understand how to set these up. Alright, so with that being said, this first one right here, we got to find the amplitude. The amplitude is your A value. Alright, so this is sine. So remember now, you have A for amplitude, sine of K plus or minus C, KX plus or minus C plus or minus H. Alright, so we have an A value, alright, which is 2, so the amplitude is 2. We got to find our period. So remember, to find our period, we do 2 pi over K. Well, first of all, what's K right here? All right, K is this number right in front of the variable. So K is 3. All right. So to find a period, we're going to do 2 pi over 3. All right, and that's what it is. 2 pi over 3. All right. Phase shift. Two ways to find a phase shift. The first way is to, well, first of all, to even identify if you have a phase shift, you must have a C value. All right, you must have something plus or minus C inside of the parentheses. Notice there are no parentheses here. All right, so there's no C, guys. There's no C present. All right, so we're going to say none. All right, no C present, so none. And then there's no plus or minus anything out here. There's no H value, so we're going to say none as well. All right. Now, let's go to number 10. Number 10 is also sine. All right. Notice right here, we have amplitude. All right. Our amplitude is the A value in front. All right. So we have A is 3. Notice A is always the absolute value of A. The amplitude is the absolute value of A. So the absolute value of this case of negative 3 is 3. All right, or you can just look at the number, not the negative sign. Then we have the period. Okay, well, we got to find K. In this case, K is 2 over 3. So what we're going to do is we're going to do 2 pi divided by K, which is 2/3. All right, not the X. I heard some people in class with 2 pi over 2/3 X. No, X is a variable. It stays there. All right, we want just the number, so 2 pi over 2/3. And then we keep change, flip, keep the top, change that from division to multiplication, and flip this bottom. So we have 2 pi times 3 over 2. All right, and if you see right here, the 2's are canceled, so I'm left with 3 pi. Now again, we need a phase shift. All right, well, there's no C right here, so there's no phase shift. So we're going to put none. And then there's no H here, so we're going to put none as well. So I'm actually going to change. I'm going to make a change, a quick amendment. I was going to do 12. I'm not going to do 12 anymore. Let's find something else that gives me a little bit more. Here, I'll do 18. I need another cosine, so I'll do 18. Well, no, that was too easy. Here, you know what? Let's do 16. 16 has everything, almost. It doesn't have a phase shift. One phase shift. No phase shift. Alright, I don't want to do 16. Let's see. You know what? Let's do 9. Let's do 9. 9 has more. All right, again. 9. All right, this is sine. That's another sine. It's okay. We'll keep it. It's sine. All right, so what's the amplitude? Is there a number right here? All right, yes, there is. I know you don't see it, but there's a number there, guys. 1. All right, or if you did the absolute value of the negative right there, well, it's still 1. Now, we got to find the period. Again, that equation for the period is 2 pi over k. All right, so in this case, you look, is there a k value right here? All right, it is 1. So 2 pi over 1 is 2 pi. Now we got to find the phase shift. To find the phase shift, guys, you take the entire parentheses, set it equal to 0 and solve. So I'm going to add pi because that's subtraction. I'm going to add pi on both sides. 0 plus pi is pi. So you have x equals pi. So my phase shift is pi. That's going to be important later. And then we have a vertical translation right here, which is 2, up 2. All right, up 2. So I'm going to put up 2. All right. Now, let's look at 13. 13 says we have an amplitude of 2. We have a k value. And the reason I chose you with k is because I'm going to make sure I keep reiterating k. All right, k is important. We got to find a period, so we use 2 pi over k, or in this case, 1/3. All right, keep, change, flip. So that's 2 pi times 3 over 1. So 2 times 3 is 6. So 6 pi. That's going to be a big graph. Now, next we have a phase shift. Guys, there's no C. Notice here we have a C, so we have a phase shift. Here, there's no C. So there's no phase shift. And there's also no vertical asymptote. Vertical shift. There's nothing. And then right here, all right, we have K. K is 4. So 2 pi over 4. Well, I'm sorry. Let's look at amplitude first. Amplitude. There's nothing out for other cosine, so there's none. Actually, no, I'm sorry. Amplitude is 1. There's a 1 there, guys. There's a 1 there. Now, period, 2 pi over k. Well, k is 4, so 2 pi over 4 reduces to 1/2. All right, or pi halves. All right. Now, there is no c value. Notice, guys, this isn't c because it's not in the parentheses with it. All right. It's outside, like it's really that. All right, so +1, which means up 1, and there are none. All right. Now, I'm going to show you how to take this information right here and make a number line. All right, but before I get started, let's talk about making our own graphs. If you look at this activity right here, notice none of these have graphs. None of them. All right, none of them have graphs. So what I want to do is teach you how to make your own graphs. All right, and here's what you got to do. We talked about it in class today. I just want to reiterate it one more time. All right. And how I'm going to do it is this. First of all, let me decide. Let's graph number 1 first. Oops. All right. And with graphing number 1, first of all, let me get another screen. All right. With number 1, we got to decide how we're going to graph this. And number 1, if you remember, 2 sine of 3x. This equation is 2 sine of 3x. I don't know why that keeps coming up. 2 sine of 3x. All right, I'm going to come back to that. We got to look at sine. All right, sine has these parent functions. Hold on, let me draw a grid. Now, I wanted to make this grid here because I wanted to make the parent functions of sine of x. All right, and we're going to use these same 5 critical points with sine. All right, so we have 0, 0. We have pi over 2, 1. We have pi. Remember acronym high. Oh, I'm sorry. It's a sign. So middle, high, middle, low, middle. So 3 pi over 2, comma 0. Negative 1, sorry. And then lastly, 2 pi, comma 0. Alright, and we're going to use these values. Alright, you use these same values every single time we're graphing sine. Here's where you would start. Alright, and our objective is to get to the last value. Alright, to the last value. So let me insert a few more lines. We got the K inverse, phase shift. Oops. And then one more line. Hold on. Alright, now the first thing we're going to look at implementing is the inverse. Alright, inverse of K. Alright, inverse of K. Alright, and you always take the inverse of K and multiply that to X. This is multiply. Alright, K inverse to X. So we know what K is right here. Alright, K is 3. So what is K inverse? 1/3. So we'll come back to that in a second. The next thing you're going to do is you're going to take X and add it or subtract it from the phase shift. Phase shift. Alright. Then we're going to take the amplitude, alright, and multiply it by Y. Alright, multiply. And then we take the Y value again, and we're going to add it or subtract it to H. Well, let's go ahead and look at some things from our graph. Alright, or excuse me, from our table that we made with this equation. If you look back at your table real quick, we wrote down that the amplitude was 2. Alright, we know what K inverse is. We already got it. Alright, you have to use K inverse. And we know that there's no vertical translation whatsoever. Alright, so all we have is 2 transformations here. We have this one, alright, which is that, and this one, amplitude. So guys, phase shift, we looked at the table. Number 1, remember, there was none. Alright, and there's no vertical, so we have 2 transformations we're going to apply. So first, how do I apply the inverse? Well, I'm going to do 1/3 times all these X values because it's K inverse times X multiplied. So 1/3 times 0, alright, is 0. So notice this didn't change, just this X value. Now I'm going to do 1/3 times pi halves. So 1/3 times pi over 2, remember multiply straight across, is pi over 6. Now, did I multiply 1/3 to this 1? Absolutely not. Why? Because I only multiply the period. The period only affects the X values. Alright, so the Y value is the same thing. Now, right here, what is 1/3 times pi? Well, again, that's pi over 1, so multiply straight across. Pi over 3. And again, the Y value did not change. Next, we have 3 pi over 2 times 1/3, because again, we still multiply to the Y value. 3 pi over 6. Notice the Y value did not change. And lastly, 2 pi times 1/3. Oops. We get 2 pi over 3. Now, notice again, the Y values didn't change right here. The only thing that was affected by K were the X values. Now for this next row, understand, there's no phase shift. The phase shift is not 0. The phase shift doesn't exist, so we don't use it. So then we go to the amplitude. Alright, the amplitude. What's affected? The Y value. All right, so we know what the amplitude is. The amplitude is 2. So I want to multiply 2 to all these y values. Now, I'm done with this column. I'm no longer looking at this column. Once I use it, I'm not looking at it anymore. Now I'm working right here, all right, with the next column I made. So the y value is affected by the amplitude. So I'm going to go ahead and do this. All the x values will not be affected. Oh man, look at me looking at the original column. See that? That's what you don't want to do. Look at this black column now. So 0, again, the x values will not change. Power of 6, power of 3. All right, I'm going to show you how to graph these in a second. 3 pi. Oh, 3 pi over 6. I can reduce that. All right, I can reduce that. 3 over 6 is going to be pi over 2. All right, and let me write it out for you. 3 pi over 6 reduces to pi halves. So pi over, pi halves. All right, and then right here, 2 pi over 3. All right, now the y values. All the y values are going to multiply by 2. So we have 2 times 0 is 2. 2 times 1, I'm sorry. Man, it's late, guys. I'm struggling. All right, here we go. 2 times 0 is 0. 2 times 1 is 2. 2 times 0 is 0. 2 times negative 1 is negative 2. Remember, that's negative 1. Low, right? Down 1. And then 2 times 0 is 0. All right, so this right here is where we're looking at now. I'm done with this. Done with those points. Now, y plus or minus h. Guys, there's no h value out here. So, and we also said there's none. All right, so we're done with that. So these are our final points. 0, 0, pi over 6, 2, pi over 3, 0, pi over 2, negative 2, 2 pi over 3, 0. And let me show you how to graph these points. So you're used to a number line, all right, and what we've been using is it was written out like pi, pi halves, pi, etc., etc., etc. All right, doesn't matter right here. All you do is look and go, what is the biggest denominator? The biggest denominator is 6. We got 0, we got 6, we got 3, we got 2, we got 3. The biggest denominator is 6. All right. So what we're going to do is count by 6. All right, 6. What I mean is here's 0, 1, 6, 2, 6, 3, 6. I'm just counting 1, 2, 3, 4, 6, 5, 6, 6, 6. All right, I can keep going. I can go 7, 6, 8, 6, 9, 6, 10, 6. All right, I'm going to stop right there because I don't think I need all those values. All right, let me move this down so I can clear this up for you. Now, are we going to use these 6 values on our graph? No, guys, because look at the points we have. All right, we have pi over 3, pi over 2, 2 pi over 3. Let me show you how to get those. If you look right here, 0, 0. Pi over 6, that doesn't reduce. That's still 1, 6. Right here, 2 pi over 6 reduces. 2 divided by 2 is 1, and 6 divided by 2 is 3. So this is pi thirds. We have that. 3 pi over 6 reduces. 3 divided by 3 is 1. 6 divided by 3 is 2. That's pi halves. We have that. All right. And then 4 pi over 3. 4 pi over 3 reduces. 4 divided by 2 is 2. 3 divided by 2 is 3. 6 divided by 2 is 3, sorry. We have that. So guys, there are 5 points. They're right there. 0, 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. They're right there. Those are the points I'm going to use on my graph. All right, pi over 6, pi over 3, pi over 2, 2 pi over 3. Okay, so you can make this graph. So I'm going to go back to my graph. Oops. Go back to my graph. Remember we said this is 0, pi over 6, over 3, 2, 2 pi over 3, 2 pi over 3, over 2, 2 pi over 3. 1, 2, 3, 4, 5. So here we go. And then we just get all the respective y values. So 0, 2, 0, negative 2, 0. Right, see that's 0, 1, 2, negative 1, negative 2. Alright, so we graph it. We got 0, 0, 0, 2, pi 6, 0, pi thirds, negative 2 pi halves, and 0, 2 pi over 3. And again, I got all those points from right here. Now, I know some of y'all are like, there's a lot. Dude, I'd rather you get it. I'm not interested in if it's being a lot or not. I want you to understand. And this is a surefire, organized way for you to get it. It's organized. All right, you can write it out and see it. I want you to understand it. You got to practice, okay? Let's do another example. I'm going to do a cosine this time with a little more things added to it that we got to do. And I'm going to do number 15. No, I want to do number 9 because there's something for every column. All right. So number 9 is I hate it's not cosine, it's sine, so I'm gonna just do that one. Nah, I'm gonna do a cosine because I want you to have the exposure of everything. I want you to see a cosine graph. So there we go. Cosine 4x plus 1. Cosine of 4x plus 1. Alright. Go back over here. I'm going to clear some things off because I'm going to use this graph again. Except some things have got to change. The only thing that changes on this graph is, alright, so now this equation is 4x plus 1. Alright, cosine of 4x plus 1. So for cosine of x, guys, I remember, oh man, I forgot to tell this off. Alright, we have high, middle, low, middle, high. So 0, 1, pi over 2, hold on, let me write that a little better. Pi over 2, comma 0. Oh yeah, pi, negative 1, 3 pi over 2, comma 0, and 2 pi, comma 1. Alright, so these 5 points you will use for cosine every single time, regardless of the cosine function. Alright, now the first thing we've got to do is we've got to identify K inverse. Alright, we already talked about what the main things are. We need to find K inverse. So K is 4. So the inverse of K is 1/4. Alright. Notice we also discovered, or we said we don't have a phase shift, so we're not going to use that one. We don't, the asymptote is 1. Alright, so 1 times any of these y values won't change. So I'm not going to look at that one. Alright, because 1 times 1 is 1, 1 times 0 is 0, 1 times negative 1 is negative 1, 1 times 0 is 0, 1 times 1 is 1. So I'm not going to look at that. Those values won't change. That's a 1 right there, so it's okay. Now, this one is interesting. I have plus 1. So all these y values are going to get added by 1. Alright, so plus 1. So let's go ahead and implement K. K inverse is 1/4. It's 1/4 x. So 0 times 1/4 is still 0. pi over 2 times 1/4. Let me write it out for you. Becomes pi over 8. See that? Pi times 1 is pi. 2 times 4 is 8. Again, notice the y values are changing. Right now I'm just affecting the x value. Alright, pi times 1/4 equals pi over 4. Alright, again the y value doesn't change. 3 pi over 2 times 1/4 becomes 3 pi over 8. And then 2 pi times 1/4 becomes 2 pi over 4, which is 1/2, or pi halves. Alright, power 2. There we go. Now the last thing I want to do is add 1 to the y values. So again, the x values will not change. The y values will. I gotta add 1, so that goes to 2. I gotta add 1, so that becomes 1. 0 plus 1 is 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. And 1 plus 1 is 2. So these are our endpoints we're going to apply. But before we do that, we got to look at our number line. Again, look in this left column. What is the largest denominator or bottom you see? 8. So we're going to count by 8. Alright, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Alright, now let's see how all those reduce. Alright, I know you're like, oh, it's so much, Coach Moore. Hey, listen, I'm being very thorough on my explanation. I could easily graze over this and it wouldn't be helpful. Alright, I'm taking time to really explain this. So 1/8 does not reduce, so pi over 8. 2 pi over 8. 2 pi over 8. 2 over 8 reduces to 1/4. 2 divided by 2 is 1. So 1 pi. 8 divided by 2 is 4. Alright, that's one of my answers right there. 3 pi over 8 does not reduce, 3 pi over 8. Alright, oh, which we have right there. 4 pi over 8 reduces. Oh, I'm sorry. I didn't reduce it. I just rewrote it. 4 divided by 4 is 1. And 8 divided by 4 is 2. So, guys, there's our 5 points right there. Alright, guys, all we got to do, look, we have 5 points. We're going to end with 5 points. 5 points. That's all you got to do is put down and connect the dots. Alright, so we go. Pi over 8, pi over 4 is 3, pi over 8, pi over 2. Alright, so I go by number line. We have pi over 8, pi over 4, 8, 2. Alright, pi over 4, 3 pi over 8, and pi halves. Alright, let me make sure one more time. 3 pi over 8. Yep. So now, what are our y values? 2, 1, 0, 1, 2. So, 1, 2, negative 1, negative 2. So we have 0, 2, pi over 8, 1, pi 4, 0, 3 pi over 8, 1, and pi over 2, 2. And there we go. There's our graph. Alright. It just continues infinitely, but we're good. There's our graph, guys. I hope this helps. It got way too long, so I'm gonna end it right here. And I will catch you in class. Peace.